Hello, so today is Car Fleet 2 problem. It's a retro session. I would like to solve this problem even though I failed it before. Um, so the problem is a little bit complicate complication over like Car Fleet first problem. So we don't have like a final uh, X like finish line. All cars are like already sorted. So the problem is the following. We have a cars. The first index, the under index 0 is position on axis, and the second one is a speed. So like this car is already ordered by the allocation, like position, and there we need to output the time when the car gonna reach the next car that's driving ahead of it. So like in this case, like car at position 4 and the next one at position 7. This one moves with the speed 3, this one moves with the speed 2. It means that this one, like the car behind this one is like going faster. That means that eventually it's gonna reach to this one and they're gonna move with the same speed of the slower car. If I go like here, again, this car is going slower than this one. That's the car ahead of it. And this car actually this car going slower than this one. It means that this car gonna never reach it's like going slower than the all previous cars, all cars ahead. It means that this car will never reach to any cars that are ahead of it. It means that we should put the -1 as a time for this car to reach the cars ahead of that. And then the following car goes with speed 2 at position 1. It goes faster than the car ahead of it, so it will reach to the car. So let me copy this one, try to explain my logic. So we have here the array of cars. This one is position X. This one is basically speed. So my suggestion is to move from the end from the last element to the first element, and then uh, have kind of every time calculate the equation. So this car, if you compare this car will no will never like it's there are no cars ahead of it, like here. So it means that it will never kind of it will never reach the car ahead of it. So we should just push, let's say we are pushing value 7 position speed 2 and we push the value -1 here, meaning that it will never this is gonna be x, that's gonna be speed, that's gonna be time when the car gonna reach the car ahead of it. And the current car gonna reach the car ahead of it. So we move the pointer now, it's like 4, 3, and we have this equation 4 plus 3 t equals 7, the car ahead of it, plus 2t. And if we like move t to the left and like axis to the right, gonna be t equals 3. So we're gonna just push the value 4 and 3 and the time when I'm gonna reach 3. So we're gonna move the pointer and like this car travels with speed equal v equals 1. So because of that, I'm gonna go through the stack, that's gonna be our stack, and gonna pop the every element that has a speed faster than the current one until I reach it. Until I kind of reach the car that goes slower than the current one. So let me try that. So like I'm gonna pop this element because 4 is greater than 2. I'm gonna pop the 7 element. So in the end, I'm gonna have an empty array and I'm gonna push the new element there. So I'm gonna push um, 2, 1, and -1. And then I'm gonna move the pointer and then I'm gonna try I'm gonna try to make to do this equation again. So this speed is actually uh, this speed 2. This one has speed 2, and this the stack top element has speed 1. Means we cannot push it because the car ahead of us going slower. So we do this equation 1 plus 2t equals 2 plus 1t, and then we move t's, and then I'm gonna have 2 t's equals 1. So we're gonna push the value 1, 2, and then speed 1. Every time we're gonna push the element to the stack, we're gonna also update the time for this element. So this one was car index 3, so we have -1. This one car index 2, so it was 3. And this one was the car index 1, so it's -1. And then this car is index 1, 0, so it's 1. Yeah, and this is gonna be the output. Yeah, in this case, it was an easy case because we either had cars that are slower than the previous one, like this one. It's slower than all cars ahead of it because it has 1 and those has like 3, and this one has speed 2. Or in this case, we had just one car that's ahead of us, and it was kind of easy to or like to um, to calculate the time when it's gonna reach the car ahead of it. The harder problem gonna be like this. So let's assume we have a car that travels like 3t, and then we have a pretty distant car, like this one is at position say 5, and then and we're gonna have like a car at position let's say 11 or like maybe 10 traveling at speed 1t, and then we have like car behind this car that travels even faster, let's 40, and let's say the acquisition is 4. Sorry, my vectors are not like, oh, this one is like, okay, so this one has a long vector, this one has a, oh, okay, it should be smaller than 40, okay. This one a pretty short one, like this one, and this one is much longer, like +1 t longer. And this one has like teeny tiny little bit vector. So in this case, if you'll consider uh, this case versus the case where we have like car that travels like 40 and then let's say position 0, and then we have car travels like 3t position let's say 7, and then not 3t like 3 meters per second, 3 meters per 4 meters per second, here like 1 meters per second, here 4 meters per second, this one 3 meters per second, and then this is first case, this is second. And here we have a position like, let's say 8, the car travels at 1 meter per second. So in the first case, we're gonna have the time when the first car reaches, when the, like, this is gonna be the first, this is gonna be the second, this is gonna be the third. First. When the second car gonna reach the third one, the time. If it travels with speed 3 meters per second, so we'll have 5 plus 3t equals 10 plus 1t. So 2t equals 5. So in 2.5 seconds, this car gonna reach the car that travels travels with 1 meter per second. What about this car? This car gonna reach what time it's gonna reach the first, the second, and the third. So the second car, if it's kind of no obstacles, kind of the let's calculate hypothetical time when it's gonna reach the second car. The second car, so like 4 plus 4t equals 5 plus 3t. And in this case, it's gonna be t equals 1 second. So in 1 second, this car gonna reach the next car. Let's calculate the hypothetical time when the first car gonna reach the third car. So in this case, 4 plus 4t equals 10 plus 1t. And in this case, you're gonna have 6 equals 3t. And then time when it's gonna reach the third car gonna be 2 seconds. So this car number 1, gonna reach the second car faster than the third car. It means that its speed gonna change to 3 meters per second when it's gonna reach the second car, and it will no longer travel with 4 meters per second. It will start traveling with 3 meters per second, and it means that we should, in this case, we should basically do what? We should somehow add this speed to the top of the stack. Yeah. And the time in this, let's calculate the second case. Uh, when let's say we have car traveling for first, second, and that's third. This one, when the time when gonna reach the car, the second car. So 4 plus 0t plus 4t equals 7 plus 3t. So 7 equals t. So this car gonna reach this one. The first car gonna reach the second one in 7 seconds. Let's calculate when hypothetical time when it's gonna reach the third car if there are no obstacles, like second car. So it's gonna be 0 plus 4t equals 8 plus 1t. So it's gonna be 3t equals 8, and the time when it's gonna reach that car gonna be what? 8 over 3, and it's 8 over 3, it's 2.66, like 2.6, let's say. 2.7, say, have 2.7. So this car gonna reach y 2.7 seconds gonna reach the so in this situation, if we gonna and let's calculate the time when this car gonna reach the next one. So let's remove this one. So the time when second car gonna reach the third one gonna be 7 plus 3t equals 8 plus 1t. Two t equals 1, t equals 0.5. So in this case, we compare the 7 seconds and 0.5 seconds. So it means that if you're gonna have a stack of, let's say, 8, 1, and then minus 1, and then next we're gonna have 7, 3, and then 0.5 here. And we're gonna like we need to figure out against which car this car gonna compete. Uh, Either it's gonna reach car number second car before it hits the third one, so it reaches the car with a speed 3 meters per second at whatever position there, or it will reach the car that's it will the second car gonna reach the third car before the first car reaches the second car. So if this car like reaches, if the car number, like if this car reaches, if the second car reaches the third car faster, that's in this case faster, than the first car reaches the second car, so like 0.5 is smaller than 0.5 seconds is smaller than 7 seconds. It means that the first car now have to compare itself with the third car speed, because as soon as the second car reaches the third car, its speed becomes the third car speed. Um, so that's basically it. So we need because this car gonna reach first the second car gonna reach the third one, and then first car gonna reach the third one. We need to calculate the time when it's gonna reach the second and third cars are gonna move in tandem based on this formula. So we have 40 plus 40 equals 8 plus 1t, and then gonna be 5 3t equals 8, and then t equals 8 over 3, and that's gonna be 2.66, no, roughly 2.7. So we need to pop the element, this one from the stack, because the time it's gonna reach the next one is um, is a is a faster than the current car reaching itself. So we're gonna pop it, and then we're gonna push the new value like 0, 4, and then 2.7 here. And this was the in this case and in this case when the in the first case when the second car gonna reach the third car uh, slower, like in the time kind of after the first car reaches the second one. So we don't need to push the pop the second car from the array from the stack, and like we need just to populate the records there. So there, let's code the solution. So let's assume we have cars. So I do this import java util stack and then stack integer. I wanna put double there, double, and then as new stack, and then I wanna push. Uh, so let's say int equals cars length. Stack push new double. I'm gonna have this double, and then cars and -1 0 cars and -1 1 and then -1, and then for int I equals n minus 2 I greater or equal 0 I minus minus, and we need basically and we have like double t equals new double, basically the output, and then we have uh, t n minus 1 equals minus 1.0, and we need to check first one, we need to check if there if there are cars while if there are cars that are faster ahead of us, faster than us. If they are faster, oh not faster. If there are cars that are slower that are ahead of us. If they're slower, we're gonna catch up with them. If there are cars that are faster ahead of us, okay, let me think about this one. Slower or faster? So we have the current car that's at position I, and we have the cars that are ahead of us. And if the car that's ahead of us and it's traveling faster than us, it means that we need to pop it. So while stack is empty, not empty, and stack pick 1, so that speed is faster or equal our cars I1, we need to do that stack pop. So the next one condition, we have this time when we need to calculate the time when the current car reaches the car that's ahead of us in a stack. So let's calculate it. Stack, so cars, so the current car travels with from 0 plus let's say t multiplied by cars I1 equals stack peak 0 plus t multiplied by stack peak 1. So we need to move the t to the, we need this one move to the left, and then we need to move this one to the right, and then we need to do the brackets, and then we need to divide the left part over this one. And this is gonna be the time when the car that's current car gonna reach the car in the stack, in the top of the stack. And if we need to do while stack is empty, while it's not empty, and so we calculate the time uh, when the current car gonna reach the current stack. If this time is greater, if this time is greater than uh, the stack peak, uh, then the time when the car that ahead of us gonna reach the next car, if this time is greater, it means we don't need to we need to pop this car from a stack. Let's say there is one example when there is one case when the stack peak is -1. This one is -1. In this case means that do we need to pop it? So it will be, and we need to check. We don't need to pop it because that will spoil our result. Stack peak 2 not equal 1.0. Otherwise, we will always kind of pop it from the head of the stack. And like the car ahead of us, it might be traveling with a speed lower than current. And in this case, we're gonna exclude it, and we don't need to exclude it if you don't account for this one. We're gonna exclude it, and we don't need to exclude it. If cars and stack peak not equals 1. No, this one. This one gonna end here. Yeah, if there we need to do stack pop, and then we need to calculate the basically the time when we gonna reach the car then in the stack. If stack is empty, then we're gonna push stack push new double, and then we need cars I 0, cars I1, and then -1. It means that in the stack we'd have like no cars ahead of us. So we push it as well. That one is the first one. And we need to also update the time for this car. Time at I equals -1.0. And else we need to push the similar one, but to the time double time equals the same one. Okay. cars E stack peak, okay, over cars, okay. This sounds to be true. This one over this one. Okay, this condition over. Okay. Double time, and then we need to stack push this card to our stack, and here gonna be time, and then we need to update the time E equals time, and in the end there might be still cars that are kind of, so the situation is if you have in the end of the cars there in the stack can be okay every time we need to return T. So let's check. Let's change it because I'm using stack everywhere. Let's make it easier. Double T. Okay. Time. Okay. Let's quickly check this one. We always have now ones. Case. So we can generally remove this and this. Okay, let's trace it. Let's trace it and figure out what's the problem there. So we push our stack equals 7 to -1. We update also t equals -1. Say no, e equals 2. We check is stack is empty. No. We check stack peak 1. So 2 is great. No, is it greater than cars I 3? Is it great? No. Stack pop. Okay, we need to also when we okay, we stick pop. Okay, is empty. So cars e. Okay, so the problem is we have like -1s everywhere there, and I need to figure out why we have it. So we have stack 7 to -1. We have I equals 2. So we check is stack empty? No. Is stack peak at -1? So stack peak here gonna be 2. Is it greater or equal 3? No. And then stack not empty. Cars e. So 4. We have 4 minus stack peak 0, 7 over 4 minus 7 over 2 minus 3. This one is equal 3. And we check stack peak 2 is actually not equal minus, okay, -1. Okay, let's run it. Okay, let's submit it. Okay, that's it. This is a solution for the car fleet problem, car fleet 2 problem. Retro. I did a minor a typo here, like, but it was, I guess, minor.